Hello everyone. In this video I will be discussing about a polygon clipping algorithm, that is the Sutherland-HODGEMAN algorithm. Now in my previous two videos I have dealt with the line clipping, but in this video I will be dealing with the polygon clipping. Okay, so now let's say we have a polygon like this. Okay, so this is a polygon and the rectangle is the window. Okay, now what we need to do, we need to clip the polygon so that no portion of the polygon remains outside the window. So we can do that in 4 steps. Okay, the first one is left clip. Now what is left clip? Left clip is nothing but clipping the part of the polygon that is outside in the left side of the window. So this is known as left clip. Okay, now remember one thing, the 4 steps that I am talking about right now, they have a certain characteristic. Okay, the characteristic is that the output of one step is fed to the second step as the input. Okay, so this was the first step, that is left clip. So first step, the left clip, that is done. Now output of the left clip is given as input to the second step, that is right clip. Okay, that is this output is given as the input for the right clip. Now right clip is nothing but removal or rejection of the portion of the polygon that is outside the right boundary of the window. So this is called right clip. Okay, now the third step. The third step is top clip. So this is fed as the input for the top clip. Now top clip is removal of the part or the portion of the polygon that is outside the top boundary of the window. So top clipping is done. Now finally we have bottom clip. Okay, now bottom clip is removal of the part or the portion of the polygon that is outside the bottom boundary of the window. So this is also done. Now as you can see, no portion of the polygon is left outside the boundary, so that means the polygon has been clipped. Okay, now this clipping, the polygon clipping, is done based on 4 cases. Okay, so we will see those cases now. Now the first case, there is case 1. Case 1 is when the edge of the polygon is from inside to outside. Okay, so the edge is from inside to outside. Then what we will do? So let's see what it means. Let's say this is the window and we have an edge of the polygon which reads V1, V2, and the edge is from inside to outside. Okay, so direction is from inside to outside. Now what we will do? We will just update the edge that is outside as V2 dash. Okay, so our output will be V2 dash. Okay, if the edge is from inside to outside, then we will update the intersection point between the edge and the line as V2 dash. Okay, and then what we will do, we will reject this line V2 dash V2. Okay, that I will show you in an example. Right now just keep the cases in mind, because that will help you in your numericals. Okay, the second case, that is case 2. Case 2 is when the edge is from outside to inside. That is, I want to say, when it is like this. Let's say this is the window, this is the edge, this is V1, this is V2, direction is towards V2. Okay, now what we will do? In this case, our output will be V1 V2 dash, sorry, V1 dash V2. Okay, that means we have to update this intersection as V1 dash, and we will reject this line V1 V1 dash. So this line will be rejected. In this case, this line will be rejected. Okay, so this will be our case 2. Our case 3 will be when we have a line completely inside. Okay, that is, we have the window and we have a line, say V1 V2. Okay, then what we will do? In that case, our output will be V2. Okay, so if we have a line inside the window, then our output will be V2. And the final case that we have, it is, you all know that, completely outside the window. So let's say this is the window and this is the line or the edge, that is V1 V2. In that case, our output will be nothing, that is nil. In other words, we can say that we will just reject this line. Okay, directly. So these are the 4 cases. Now I will show you each case through an example. Okay, so let's see that example. If you want, you can note down these cases, as they will help you in doing your questions. And I will suggest you that when you attempt any question in your examination, then try to write down these cases as rough, and then you solve the question, because that will help you, and that would reduce the chances of making mistakes. Okay, so let's see the example. Okay, now the example. The example says we have a rectangular window. Okay, now the rectangular window is there and we have a square. Okay, we have a square. Okay, and the points are marked as V1, V2, V3 and V4. Okay, now let me just extend the boundaries. Okay, that will help me and also help you to understand. Now what we will do, as I mentioned at the starting of the video, that we need to do 4 clippings, the first one being the left clip. Okay, so first is the left clip. Now for each clipping, there is left, right, top and bottom, we need to write all the edges separately. Okay, and for each edge we need to perform the 4 cases that I just mentioned a few minutes ago. So I will write down the edges first. So the first one is V1 V2, then we have V2 V3, then V3 V4 and finally V4 V1. Now as you know, the first one V1 V2, it resembles the second case, that is from inside to outside. Okay, so the output will be V2 dash. Okay, so we will just rename it as V2 dash. So it will be V2 dash. Then we have V2, V3. Since it is completely outside the left boundary, so this is the left boundary, it is completely outside the left boundary, therefore we will directly reject it. Then we have V3, V4. Now for V3, V4, we can see that it resembles the first case, that is from outside to inside. That means what we will do, we will write V3 dash V4. Okay, so V3 dash V4. V3 dash, we will just rename it as V3 dash V4. Okay, and finally we have V4, V1, which is completely inside the left boundary. So we will write V1, that is the second endpoint. So our left clipping is done, and we will update the picture. So the picture will look something like this. It is extended. So this is V2 dash, this is V1, this is V4, and this is V3 dash. Okay, so our picture will look something like this. Okay, now we will perform the right clip. Right clip. Okay, now for right clip, we will write the updated edges. The first one being V1, V2 dash, then we have V2 dash, V3, V2 dash, V3 dash, then we have V3 dash, V4, and finally we have V4, V1. Okay. Now, as you can see that no edge is outside the right boundary, therefore no edge will be directly rejected. Okay, so in this case we will just write the second endpoints as this follows the case where all the edges or all the points are inside the boundary. So that means here will be V2 dash. So this will be V2 dash, V3 dash, V4 and V1. Okay, now we will perform. So this will remain as it is and it will move to the next step, that is top clip. So we will perform the top clip. So again the same set of edges will continue here. So V1, V2 dash, V2 dash, V3 dash, V3 dash, V4 and V4, V1. Now as you can see in the top clip also no edge passes the top boundary, therefore the same result will continue here. So this will be V2 dash, V3 dash, V4 and V1, and the same figure will continue as the input for the final bottom clip. So we have the bottom clip. Okay, and the edges will also remain same, that is V1, V2 dash, V2 dash, V3 dash, V3 dash, V4 dash, V4 and V4, V1. Now as you can see, we have parts of edges outside the bottom boundary. Okay, so we have to perform clipping. So for the first edge V1, V2 dash, no clipping is required because it is inside the boundary. So we will write here V2 dash. For the edge V2 dash, V3 dash, it has a portion which is outside the boundary. That means we need to perform the clipping. So we will update this intersection point as V3 double dash. Okay, and we will write that here. So V3 double dash. We are writing V3 double dash only because it follows the case number 2. Okay, that is from inside to outside. Now we will be moving on to the third edge, that is V3 dash, V4 dash, which is completely outside, and hence we will reject it. And the final one is V4 V1, which is partially outside the boundary and partially inside the boundary. So we will update the intersection point as V4 dash, and we will write it here as V4 dash V1. Okay, because it follows the case where the edge is from outside to inside, so our updated picture will be V1, V2 dash, V3 double dash, and V4 dash. So our polygon, this polygon has been clipped, and this was the Sutherland-HODGEMAN polygon clipping algorithm, and this was the last video of my computer graphics course. Hope you enjoyed the course, and stay tuned to my channel for my other courses. Thank you.